to welcome any questions on the chat function, and we'll say them out loud.
Right. Go over the one that Mike asked.
So earlier, so I think everyone can see the chat, but Mike asked earlier if the water wells are the ones from the pre-mining survey. And yes, they are. And they're used as the points for prediction in order to have the potential to validate against water level measurements. We've looked at different ways of doing that spatially, whether to do that the prediction at boreholes or whether at the water well locations. And we use the water wells to have that internal validation. However, Mike, your next question is a great one. If there's not enough pre-mining data, does that impact model accuracy or require supplemental data? So there are different ways that you could deal with that. Essentially, those water well locations are used as the points that you predict, and so you're running the algorithm at. But the data that you're using is primarily lithology, and so you could use you could copy your borehole locations into your well table and use both your boreholes and your wells as prediction points when you set up the model. And we'll detail that. We have a detailed users guide that we're still finalizing, and that will have a troubleshooting and if you need to troubleshooting and ways of working with it that are not the straightforward wells here and boreholes here. And so using the boreholes is we think the easiest way of expanding the number of locations at which you predict, but because there are no measured water levels at the boreholes necessarily, except for where a driller hit water, which we know could be accurate or not so accurate. That's our recommendation in that way, and so we'll have that written out in the user's guide as well.
Can I add something?
Absolutely. Dina wants to add something.
Okay, so we have used the wells because we have their elevation of the water to develop the model, but in reality, you don't use the water levels. Once you input the model, you run the model. What you use is only the lithologies, the coal extracted. And in this, I want to clarify that the cumulative coal extracted, we found, how much coal had been extracted in the mine at the time that they measured the head. So in other words, the program can predict basically the elevation of the head at any stage of the mine development. However, at the very end, what we are doing is, calculating the heads at the bottom of the coal layer using the model. In other words, we assume that we are extrapolating, the information for the boreholes or the wells, and then, finding the head at the very bottom of the coal so that we can see if it is going to be higher or lower than the elevation of the topographic elevation. So I don't know if you have any more questions regarding to that. So.
Does anyone else have questions? And we are also available by email if something comes up, and we're going to post these slides and a recording of this presentation on the project website. So after the second webinar, we're going to post the package tool, the theses that are associated with the project, both recorded presentations and the user's guide and the fact sheet that we're developing for OSM will all be posted on our project website on watersheddata.com. I see Ben and Mike are typing, so we'll wait until those pop up. All right, so in developing the model, did you develop a feel for how different the model prediction was versus the top of coal method? So we've looked at mapping our predicted water levels against the top of the coal, and about half the time we were higher and about half the time we were lower. And I would need to look back at that data analysis to give you a magnitude of that, but yeah, I'd say it wasn't consistently that we were predicting higher, we were predicting lower, but about half the time higher and about half the time lower. All right, so Ben asked, how transferable would this be to other states, since the geological and GIS data is specific to Ohio that would need changes for another state, but would the model algorithms need to be changed and refined as well? So our recommendation would be that we would update algorithms state by state. But we've done, in developing the method of developing that algorithm, that was a significant amount of work. And so it'd be so much easier to update that state by state. And so that would certainly be one of the obvious next steps would be to get data, hopefully in a fewer PDF pages format to expand that to other geographical areas. Because, ultimately this is an empirical model. And so it's based on the data that we used to develop it, which was for Ohio. And so the most scientifically defensible thing to do would be to update that algorithm with geographically specific data for what it's worth. So that would be I think that would be a really useful and exciting thing to do. But really developing the methodology for all of this has been kind of probably the most significant part of this. So it's really pretty, I'm going to say easily transferable, but it really is based on the data. But the methodology is easily transferable.
Yes. Can I say, with respect to developing the model for all of the states, we are lucky here in Ohio that we have a region for the coal mines where the geology is very similar. In other words, we don't have too much variation. We have variations, but what I want to say is that, the cyclothem, are more or less, repeated, all over the coal area of Ohio. So if we do it per state, we have to be sure that what we are doing is considering areas that have similar geology. I think that, probably more important than doing it by a state is doing it in areas with similar geology, but and within a state, maybe you have one or two areas or whatever, that, you need to classify and then do the approaches as appropriate.
Yeah, so rather than political boundaries, geological boundaries.
Exactly. Yes. So, obviously, one thing that is necessary to point out here in terms of the prediction is the fact that our predictions about the surface, the water levels getting above the surface will depend also on how many data points we have. So far our predictions, I think, that are good per point, but in terms of superficial distribution of the elevation of the water, that doesn't depend on the program. It doesn't depend on us. It depends really on how much data the mine have collected. So, one thing that is probably going to be a good extension of this, project is to really have a student doing a thesis, for example, in determining what is the, best, distribution of points that we need to really be able to predict the elevations for the whole surface, within some range of error. So right now we cannot do it with the data that we have because we don't have really an optimum, distribution of points for the different mines. There are mines that some of the points are concentrated in one corner of the mine instead of having a good distribution and so on. So that has been one of the more challenging things for us, to really, look at the data and find out, what is the situation and what we can do with that data. So we have our limitations, obviously.
Yeah, Sarah's typing. So how do the prediction errors from room and pillar mining vary from longwall mining, if at all? How do their algorithms account for various types of mining? So we don't see really a difference between the prediction errors between the two. And as we were doing the analysis, we divided them and we put them together, and there wasn't really a difference. And so we have combined the data sets into one. And so they're not treated, they're not actually treated differently with the algorithm because it didn't make statistical difference.
Well, yeah, and the reason I think it is very easy, the reason is mainly because we are considering the cumulative coal extracted. So, if it is longwall mining, it's going to be greater fraction of the area that is have had, the coal extracted. If it is, pillar room, then we have a lower, level of coal extracted. So I think that that's the reason why we cannot see a difference, a significant difference, when with respect to the type of mining.
All right, we'll leave it open for a few more minutes for any additional questions. But again, if you think of something later, you can reach any of us by email. But I'd suggest maybe sending them through me. My email is krusen@ohio.edu, and I'll make sure that the appropriate team member can answer questions. Next. Answer. All right, Mike asks, is there an error in the prediction? In other words, a plus or minus range that's predicted. So yes, there is error, and we track that error throughout. We are still working on how to symbolize that in the output. Generally, what we've found so far is that it's approximately a 1% error. So Sarah asks, would you consider the statistical model to be a black box approach, or can or will you explain the interrelationships of variables in the final model? So because it's an empirical model, and the way that the artificial neural network algorithm comes up, it does end up being a little bit of a black box approach. However, because we did the multivariate statistical analyses ahead of time, we have significant information about how the variables interrelate in the relationships to water level. And so we're able to talk about those relationships while the algorithm itself that's being applied, which is a lower error algorithm than the one that comes out of the traditional multivariate statistical approaches. While that is a little bit more of a black box, those relationships have come out through the multiple statistical analyses that we've done on the data.
And the other thing that I think that it is important, in the past, one of the persons that reviewed our report was, talking about the consideration of the different parameters that normally we use in hydrology, to determine water levels. I explained at the time that, really this is not deterministic, but a statistical model. However, if you look at the variables that we are considering, those are the variables that are necessary for any deterministic model. So hidden within, the relationships that the artificial neural networks find, it is the fact that these variables are determining, the elevation of the water, even when we do, a model that is based on the questions that define the hydraulic head. So, even when it is, a statistical model, the fact that we are considering the normal variables that are involved in a hydrological deterministic model, it really makes the model stronger, I think, theoretically.
So while we leave a few more minutes for people to think of things, I just want to remind everyone that our second webinar, and this is one where we're going to show you how the tool works and walk through it in ARC Pro, is on March 20th from 10 to 11. And we will send out emails to this whole list, and we'll ask those of you who know of other people who may be interested to share that wider as well. Yeah, and people who may be interested in using this. And again, like I said, we'll have the theses that each of these students have produced on the website, and that gives significant theoretical backing to everything that's happened, and then a user's guide that's more nuts and bolts of how to use the tool will all be available on that website. Before that webinar.
And the other thing is that we will
not Becca's thesis. Becca's thesis won't be available before that webinar. She won't be done yet.
But the other thing is that as we are going to have, the guidelines to use the program and so on, we will appreciate if you try it and see, that everything works okay with respect to the guidelines, so that we can correct them in case we have some things to add or explain better. So, that's going to be really a great, a great thing for us, because we need really to optimize the guideline.
All right, we just want to thank everyone for being here, and thank you everyone. Oh, Dave might have a question, but I'm going to thank everyone anyway. We want to thank. He said thank you, thank you all for being here today. Again, if you have any questions, feel free to email me, and we invite you to join us on the 20th. So look for that invitation. And again, yes, this presentation will be available, Mike. And we want to also thank everyone who's sponsored and supported this work.